Okay, reviewing for the test. Choose the best term from the word list. Write it on the blank. Another name for collected information is, pick a color, data. A value that is very different from the other values in a particular data set is an outlier. A blank is a display of responses on a number line with a dot or X used to show each time a response occurs. A line plot. Circle the outlier. So the number that's way different than the other stuff. 4, 32, 42, 43, 50, 76. 1 1/2, 1 3/4, 0, 1 2/3, 13 1/2. Careful on this one, because this 13 1/2 is way far away. 0 is close. And number 7, 101, 37, 40, 42, 33, the outlier. The value close to 0 on a plot line is sometimes an outlier. Sometimes it is, sometimes it's not. A data display sometimes has an outlier. They don't always. Cross out the words that are not examples of items that contain data. Encyclopedia, you probably don't even know what those are, that are not examples of things that have data. The alphabet technically are letters. Email address, it's an address. MP3 player, I guess, I don't know. Phone number, it's just a bunch of numbers. Grocery list, definitely. So that one is for sure. Has data tables, quantities, like encyclopedia is going to have, the square footage of an island or the number of people in a population. Grocery lists obviously have lots of info. I need 4 pounds of butter. That's data. MP3 player, I don't know about that one. Music, I guess. I don't know. I guess it has data. It's your call on that one. And then 20 students measured their height for an experiment in their science class. How can a line plot help analyze the results? You'll be able to compare you can use the line plot. The line plot organizes data. So you can make, so you can interpret it. So you can look and see what is similar, what's different about the data. You can see if there's any outliers. You can look for the least and greatest value, and so on, using a line plot. Awesome tools for science. And our reteach, how many soccer games scored 3 goals? So we go over and look, and we see on our data, there the data set shows number of goals scored by 20 teams. So there's 20 teams. We have 2 teams scored 3 goals. How many teams scored more than 5 goals? So that we'd have to add all that up together. And there's 9 teams. What was the greatest number of goals scored by a team? And that's our largest value there. So it would be 8. How many teams scored only 2 goals? Where do we see 2? 3 teams right here. I already have that one circled. What is the difference between the greatest and least number of goals? So we have 8 minus 0 equals 8. Remember that you can make a line plot to show data and compare data. So we're going to use our data here to make a line plot. We can, I guess, skip the table here. I don't know why they're doing that, but whatever. So actually, I think I want to put it in a data table. So I'm going to start from least to greatest. I have 3/4. Actually, I've got something smaller than that. I've got 1/2. I've got 1, 2, 3, 1/2, and that right there. I have 3/4 once. I have 1, 1, 2. I have 1 1/4 twice, and I have 1 1/2 once. And I can see I have all the values because I crossed them out. So make my little data table here. I've got a 3, a 1, a 2, a 2, and a 1. So this is my tally, this is my total, and this is my value or my amount. So I can go back to my little chart and I can put X's or little dots or whatever you want to use here. So if I say 3 1/2, 1, 2, 3, 3/4, I have 1. The whole number 1, I have 2. 1 1/4, I have 2. And 1 1/2, I have 1. How many dots are on the line plot? I should have 3 plus 1 plus 2 plus 2 plus 2, just to double check. So I should have 9 and, 9. And I can double check there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure you got everything in there. How many inches of plant growth was the most common? And 1/2 is the value that has the most data. Okay. And remember that you can multiply each data value by its frequency to find the total amount. So what values are multiplied in the third column of the table? So let me pull that up a little bit. What values are multiplied in the third column? We're multiplying amount of flour times frequency. So we're multiplying the amount, wrong tool, amount of flour multiplied by frequency. Write and solve an equation to find the total amount of flour Cheyenne needs. So we would take all our data here and we take our data and just string it together. And again, like I told you earlier, you can use a fraction function calculator for this or solve it all out longhand. Times 1/2. And they have it all there for you. So you can also just go through and add the totals right here, and you're going to wind up with 10 1/2. So I'd say 2, 4, plus 3 is 7, 8, 9, plus 1/2 1/2 is 10, plus 1/4 1/4 is 1/2, so 10 1/2. And the last one, remember you need to carefully consider the parts of an argument. So Justin said the line plot shows that the daily rainfall for the last 2 weeks is about an inch. Do you agree with this reasoning? Why or why not? Well, let's take a look. So he's saying it's about an inch. An inch would be right here. And really, nothing is over that except one of the days with 0 rainfall. But he's saying rainfall. The rainfall for the past 2 weeks is about an inch a day. You could say that. So if you add everything together, so if we add 1/2 plus 1 times 3, which is 3, okay, plus 2 times 1 and 1/2, plus 2 times 2 and 1/2, plus 3 times 2, which is 6. So let's see what I got here. 1/2 plus 3 plus, this will be 6 down here. 2 times 1/2 is 1. 2 times 1 and 1/2 would be 2 times 3/2. 6 times 2, which is 3. So I say 3 plus 6 plus 1 is 13.5. Let's see. Wait a minute. Oh, I miss here. 1 times 3, 6, 12. 2 times 3 times 2 is 6. 1 and 1. And then 0 times 4. The total rainfall is, let me double check this. So 1/2, that's 3.5, plus 3, 6.5, plus 5. Oh, I know what I did here. This is 2 times 2.5. Silly me. So there we go. Now that's better. So we have 17 and 1/2 is the total. And if you take 17.5 and you divide it by 2 weeks, which is 14 days, your answer comes around 1 inch a day. So that one says, we can say yes on that one. That's it.